Hello students, welcome back. Today we'll start with exercise 7.8 of chapter 7, that is integrals. Okay, I hope you had watched my all the earlier videos. Till now we had discussed till exercise 7.7. We had completed till 7.7. So if you like my videos, then please subscribe to this channel. Okay, now till now we had studied about indefinite integration. From this exercise, we are going to enter in definite integration. Okay, so now let me first tell you what is definite integration. See, till now we were solving the sum like this way. Means this was not having any lower limit, any upper limit. But now, in this case, you will be having lower limit and upper limit. Okay, so now this is definite integration. Okay, just take, I'm getting you example. If this is a curve of fx, okay, now if this is the point a0 and this is the point b0, okay, means when you are integrating from a to b, means you are starting from here and ending at this point B. Clear? In the next chapter, that is application of integrals, we will study in this way. In this way, we will be finding out the area under curve. Like from A to B, when we are integrating, we are getting the area under this curve. If I'm integrating from this point to this point, okay, then I am getting the area under this much curve. Okay, so this is definite integration. So in definite integration, there will be no constant c at the end. Clear? So this was about just basic introduction about definite integration. Means we are starting at A and ending at B. Okay, this type of sum you might already studied in some other subject physics, right? Just give me a short example. If it is like this, x square dx from 2 to 4, right? So in definite integration, what we are doing? Integration of x square, x cube by 3. Now we are not going to write down plus c. It is from 2 to 4. Okay. So we have to start from 4 and start from 2 and end at 4. So what I am doing? First I am calculating till 4. So putting the value here as 4 cube by 3 and then subtracting the value till 2, 2 cube by 3, right? So it will be from 2 to 4, right? So it will be 4 cube, that is 64 by 3, minus 2 cube, that is 8 by 3. Okay, so 64 minus 8, this will be equal to 56 by 3. So integration of x square dx from 2 to 4, this is the answer, right? But this is the direct method, right? In the first exercise, in 7.8, we are going to use the method of limit of sum, right? You can verify your answer by this method. Okay, but if the question says that find out the integral using the method of limit of sum, okay, then in the exam you should not write this method. Okay, so let me explain you now what is limit of sum. Okay, now when the question is about limit of sum, then you have to answer this by this method. Limit h lengths to 0 at summation of f of a plus I h. We will be using this method, limit of a sum, right? Now, what is h? Okay, then h will be equal to b minus a by n, or I can also write down n will be equal to b minus a by h. When here we are doing summation, where I will be equal to 1 to n. Clear? Okay, so I can use h or n. Most of the time we will be using nh. That will be equal to b minus A, okay, where this lower limit is A, upper limit is B. We can also use instead of h length to 0, n lengths to infinity. See, when h is equal to 0, n will be equal to infinity. Clear? So, just note down this formula. When the question says solve the integral using the limit of a sum, you have to use this formula. Okay? So, just note down this formula. Okay, now before starting the exercise, let me revise you some formulas that you are studying in standard 11 based on limit and based on summation, means in sequence and series. Okay, so let me revise you some formula. Okay, the first is summation of I, where I is equal to 1 to n. This will be equal to n plus 1 upon 2. Okay, summation of I square, I equal to 1 to n will be equal to n plus 1 2n plus 1 by 6. Summation of I cube, where I is equal to 1 to n square, m plus 1 square upon 2 square, that is 4. Okay, see, it's easy to remember this formula. Just square all of them, you will get the formula for I cube. N square, n plus 1 square, and 2 square, 4. So these are the three formulas for summation. Then it is summation of phi I. Then phi is constant, take it out. So phi into n plus 1 by 2. Yeah, if there is a constant like summation of a, I equal to 1 to n, then this will be equal to an. Okay, this means we are adding a from 1 to n. We are adding a for n times. Clear? So these are the formula for summation. Clear? Now, when there is a geometric progression, okay, when there is a geometric progression, okay, then the summation of ratio, that means summation of the n numbers will be equal to a r raised to n minus 1 upon r minus 1, right? You have already studied this formula in standard 11. Clear? Where a is the first term. Let's take example 2 plus 6 plus 18. Okay, so if these three numbers are there, then a is equal to 3. Ratio r will be equal to 6 by 2 3, or I can also write down 18 by 6. That is also, I got r equal to 3, right? So if the series is for n terms, then a will be equal to 3, r will be equal to 3 raised to n minus 1 upon 3 minus 1. Clear? So this will be for the Sn. Now, limit. There will be some sum based on the exponential function. Limit e raised to h minus 1 upon h length to 0. This will be equal to 1. This is also the formula that you have studied in standard 11 in the chapter limit and derivative. Right? So limit e raised to h minus 1 upon h equal to 1. Okay. Now, sometimes if there is 3h, let's say if it is like this 3h minus 1 upon h. So in that case, what we will do? We will multiply it by 3, divide it by 3. So now instead of h, I am having 3h, 3h. Now if h lengths to 0, then 3h, 3 into 0, that will be also equal to 0. Okay, now it becomes this formula. So it will be, this equation will be 1 into 3 is the constant. So 3 into 1 equal to 3. Okay, so we will be dealing with some type of sum, so we will do this technique in that type of sum. Clear? So this is about e raised to limit e raised to h minus 1. Okay. Now, if it is like this, n tends to infinity, we will be also having some intermediate steps like this. At that time, when I am putting the value of n as infinity, it will be 5 plus 0. Clear? So this is also one of the type of intermediate step. Okay. So at present, just note down this formula. Okay. You will be using this in exercise 7.8. Okay. So note it down. Okay, now let's move to exercise 7.8. Let's begin with exercise 7.8. Okay, today we'll study two or three sums based on this formula. Okay, so let's begin with the first one. The question one is integration of x from a to b. From a to b, integration of x dx, right? So the question is, you have to find out this integral or you have to integrate it using the method of limit of sum, right? Or else if this is asked in MCQ, you can directly solve it in this way. If it is an MCQ, integration of x square by 2 from a to b, right? Now just put the value. First we'll put b minus a. So this will be equal to b square minus a square by 2. You got the answer, right? But the question is limit of a sum. If it is MCQ, solve it directly. If it is not mentioned anything, which method? Solve it in this way. But if the question says using the method of limit of sum, then you cannot use this formula, this method. Okay? So let me first note it down our method. What was it? Integration of a to b fx dx, this was equal to limit n tends to infinity or h tends to 0 h summation of f of a plus I h, right? So now in this question, what is fx? Fx is equal to x, right? What is a and b is equal to b, right? Now what is h? B minus a by n or nh equal to b minus a. Okay, accordingly we will use any one of this. Now what is f of a plus I h? What is f of a plus I h? F of x is equal to x, so this will be equal to a plus I h. Here f of x is equal to x, that means f of a plus ih will be equal to a plus ih. So now what will be our integral? Limit n tends to infinity h summation of f of a plus ih I equal to 1 to n. Okay, see I am just using this formula, I just put it. Now just recall what is a, f of a plus ih, h summation of what is f of a plus ih? A plus ih 1 to n. Clear? So now limit n tends to infinity h. Now a is constant, right? So I had already discussed it earlier. When it is summation of a, then the answer will be an. It is 1 to n, so this will be an. So the question says that if it is I equal to 1 to 5, then it will be 5. So here it is 1 to n, so it's an plus h. summation of I equal to 1 to n. See here, h is constant, so I've just taken it out and summation of this. So now this will be equal to limit n lengths to infinity. Okay, an plus h. What is the formula for summation of I? I equal to 1 to n plus 1 by 2. So it is n plus 1 by 2. Clear? Now what I will do, I will multiply this h. A n h plus h square n. Now see, from this 2 I have taken it out. So now this is n plus 1. Now what I can write out, I can take n common. So it is 1 plus 1 by n. See, n into 1, n into 1 by n, 1. Clear? So in this type of sum, what we are going to do, we are going to take n common. So 1n it is already having, and 1n I am taking common from this, so it's n square. It will be 1 plus 1 by 2. This 2 I have taken it out. So this is the final thing. Okay. Now we are having the value of nh as b minus a, right? So limit n lengths to infinity a into b minus a plus what will be h square n square b minus a whole square. Sorry, it's 1 by n. Okay, clear? Into 1 plus 1 by n. Okay, what I can do, if I remove this limit, I have to put the value of limit n. So when I remove this limit, okay, putting the value of infinity, this will be equal to 1 by infinity, that will be equal to 0. Clear? So here a into b minus a plus b minus a whole square by 2. LCM will be equal to 2. Clear? 2a b minus a plus b minus a whole square. Okay, b minus a is common in both upon 2. Okay, this 2 I have taken count. So here will be 2a plus it's b minus a square. So we have taken one b minus a, it will be b minus a. So b minus a by 2, b plus 2a minus a. Okay, so this will be equal to b plus a. So b minus a, b plus a, b square minus a square by 2. Okay, clear? See, I have done all these steps. Sometimes you can use direct step. Okay, you can do for calculation directly. Clear? So let me erase this. Okay, so this was about question number 1. And repeating once again. See what I had done. I had taken fx equal to x, a equal to a, b equal to b, h b minus a by n, or nh b minus a. Clear? So now f of a plus ih, I want that. So this will be fx equal to x. So f of a plus ih, a plus ih. I put the formula. A is constant, so it's an ih. I have separated, h is constant, and instead of I, this. You can use directly from here this step. Okay, if you are familiar with it. Okay, now what I done, I'm taking common here. See, this step we will be using in the next sums also. So I'm taking n common here, so it's h square n square. Now I put the value of nh. And also I remove the limit, so put the value of ns infinity, so it's 0. And then solving it, finally I got b square minus a square by 2. Okay, so if it is limit of sum, you have to use this method only. Or else, if it is not mentioned anything, or if it is MCQ, use the first method. You will get the answer in very short. Okay, you can also verify your answer by that method. Clear? So now just go through question number 1. Okay, so now let's move to question 2. Question 2 is integration of x plus 1 0 to 5. Okay, clear? So now first let's take what is a 0, what is b 5, okay, what is fx x plus 1. So what will be f of a plus ih? F of a is 0, so only remaining ih. So this will be equal to, instead of x, I will put ih. ih plus 1. Clear? I'm repeating a0, b5, f of x. This is the function. So a plus is, putting the value of a, I get ih plus 1. Now what is h? B minus a by n. So this will be 5 minus 0 means 5 by n, or nh is equal to 5. Clear? Now putting the formula, I is equal to limit n lengths to infinity at summation of f of a plus ih I equal to 1 to n. Here, so now just replacing it with the values. What is f of a plus ih? Ih plus 1. Clear? So I just put the value. Now, limit n lengths to infinity h. H is constant. Okay. So summation of n plus 1 by n plus 1 upon 2. Okay, h as it is, summation of n plus 1 by 2. Okay, one constant, so this will be 1 n. Clear? So now what I will do, I will multiply this h here. Okay, h into h square, n by 2. So n plus 1, I will take once again n common. So it's n square, 1 plus 1 by n. We used this method in the previous sum also. Plus h into n, nh. Clear? So now limit, okay. Now let me remove the limit and put the value of n square h square. What is nh? 5. So 5 square 25 by 2. 1 plus infinity, 1 by infinity, 0 plus nh. What is nh? 5. So this will be equal to 25 by 2 plus 5. So LCM 25 plus 5 is 10. So this will be equal to 35 by 2. Clear? Okay, it's just simple. I have just put the formula. I had already found out all the value A, B, NH, f of A plus IH and replaced it here. Clear? If you want to confirm it, that whether your answer is correct or not, you know that. What is integration of x? X square by 2. What is integration of 1? X. So it's 0 to 5. First put the value of 5. So 5 square by 2, 25 by 2 plus 5 minus. When I put 0 here, it will be 0. Here it will be 0. So again, it will be 35 by 2. You can take a confirmation by this method. Okay. But if it is limit of sum, you have to solve it by this method only. So let me erase this. Okay. So just go through question number 2. Okay. Now let's move to the next question. Question 3. Question 3 is integration of x square from 2 to 3. Okay, let me confirm the question. Yes, it's 2 to 3 x square dx. Okay, so what is our a? 2. What is our b? 3. Right? H, b minus a, so 3 minus 2, 1 upon n, or nh is equal to 1. F of x, x square. F of a plus ih, f of what is a? 2 plus ih, so this will be 2 plus ih whole square. Fx is x square, so 2 plus ih, 2 plus ih whole square. So this will be equal to 4 plus a plus b whole square, a square plus 2ab plus b square. So 2ab means 2 into 2, 4ih plus I square h square. Clear? So this is f of a plus ih. Okay, so I found it all this thing. Now let's start with the formula. I will be equal to limit n tends to infinity h summation I equal to 1 to n f of a plus I h. Limit n tends to infinity h. Okay, summation I equal to 1 to n 4 plus 4ih plus I square h square. Clear? So now we will begin. Limit n tends to infinity h. 4 is constant, so summation from I to n, 4n plus. In this, 4 and h are constant. Okay, so summation of I, n, n plus 1 by 2 plus h square constant, summation of I square, n, n plus 1, 2n plus 1 by 6. Clear? So now limit n tends to infinity. See here, 4, 4n, 4h constant, I n n plus 1 by 2. H square constant, I square, so n n plus 1, 2n plus 1 by 6. So see what I am doing, h 4n, or I am also multiplying here, 4nh plus 4h into h, or let's say 2 ones are 2, 2s are, so 2h into h, 2h square. Now see, I am taking n common from this both bracket. So one n from here and one n from here. So n square. Say 2n. One n from here and one n from here. So here I have taken common, so it's 1. From here, instead of n, 1 plus 1 by n. Got it? See, 1 n from here, 1 n from here. So n into 1, n and another n into this, n plus 1. Plus h into h square, h cube. Let's take this 6 here. Okay, clear? So now see 1, 2, 3. I am taking n common from all these three. So 3n should be n cube. Clear? From here it's 1. From here 1 plus 1 by n. And from here 2 plus 1 by n. Clear? So see 4nh, 2h square n square, 1 1 plus 1 by n, h cube n cube by 6, 1 1 plus 1 by n, 2 plus 1 by n. Now I will remove the limit. So at every place where there is n, I will put the value infinity, and when there is nh, I will put the value 1. So this will be equal to 4 into nh1 plus 2 h square 2 into 1 square into 1, so it's 1 plus 0 plus h cube n cube means 1 cube by 6 is 1, so no need to write down. 1 plus 0, 2 plus 0, so 4 into 1 4, 2 into 1 square into 1 2, 1 cube by 6, 1 cube into 1 into 2, so it's 2 by 6. So 2 ones are 2 threes are clear. 4 plus 2, 6 plus 1 by 3, taking LCM. Okay, 6 threes are 18 plus 1. So this will be 19 by 3. Clear? Okay, so this was question number 3. Remember in this type of method, see there are 3 things, so take n cube common, and whenever there is n, put 1. And whenever there is numeric, take n in the denominator. See it's n1. 1 by n in the denominator. 2n, so I have taken n as 1, 1 by n. Clear? So wherever there is 1 by n, you can take the value 0. Clear? So this was question number 3. Just go through this question. Okay, so that's it for today, right? In our next video, we will continue with this exercise. We'll try to complete this exercise in our next video lecture. Clear? Thank you.